Great job of getting data on 3 different trials for both your warm bubble tube and your cold bubble tube. Before we can move on and get to the graphing, I need you to do this. Look at your data tables for each of the trials, of the 3 trials. Which one looks like the best trial, the one that you got the best data for both the cold and the warm? Does it have the best pattern throughout all the different time intervals? Does it have the best, maybe the most data that you collected there? Go ahead and circle the trial that you're going to use that you think was the best trial for both your cold and your warm. That's the one that we're going to use for graphing your data. Go ahead and do that now. Now that you've picked your best data for the warm and your cold, we're looking at this graph. We've got a blank graph in front of us. Go ahead and turn to this page on your lab. Before I can do anything with a graph, I have to put a title on the top of it. And because we've got data for our position of the bubble and for each time of the bubble, we're going to label this position versus time on the top. Go ahead and follow me along as you write it in and put position versus time as the title on the top of our graph. Awesome. Every graph has to have a title on the top of it so we know what the heck we're looking at. All right. Second thing we have to do before we can begin doing anything, we have to label the axis. Right here in blue, this is the vertical axis. Right here down here in red is the horizontal axis. Because we are looking at position versus time, we're going to label the vertical axis position. Go ahead and write position up the side of the vertical axis. Now, I told you as you were gathering your data to record in centimeters the position of the bubble. So we also need to label the units on the position. Go ahead and label the position with centimeters as the units. cm. Fantastic. On the horizontal axis, we're going to put our time there. And every time you heard the metronome go off, that was a second. So my time is labeled on the horizontal axis, and my units for that are seconds. SEC, the abbreviation I'm going to use. Now there's a couple rules when we're graphing data. We want to take up as much of the graph as possible. Here's an example. We wouldn't want to graph our data and have it look like that and turn it in. Why? Because we didn't use all this space over here. So better would be to set up our data in our data table so that we're using as much as possible. The green line uses as much of my graph as possible. That's better use of the space. That follows the rule of trying to use at least 2/3 of the data. So I'm going to take that off there. As I look at the data that I collected for each of the bubble tubes, I look at and I see that if I can put great, now that we've got that announcement. All right, so if I go up and have 100 centimeters of plot on my vertical axis, then I'll be using a lot of the graph and be in good position. So watch how I'm going to do this. At the beginning, oops, sorry, I didn't mean to get rid of that. In the corner of every graph is a 0. Go ahead and put that on there. That's telling me I've got both 0 centimeters and 0 seconds on that one. So I've got 0 there. I'm going to go up on the horizontal axis and label my centimeters. What looks best for my data is to go up by every other one and go by tens. So look at how I'm going to do this. I'm going to skip this line, and I'm going to put a line here showing 10 centimeters. I'm going to skip this line, which is showing 15, and I'm going to put a line on the second one showing 20 centimeters. Skip a line, 30. Skip a line, 40. Kind of see where I'm going with this. Go ahead and do the same thing on your data table. And if I do this all the way up, this is going to take me to 100 centimeters. I think that will have me using close to 2/3 of the graph, just like I explained it to you. And I also, even though I didn't label the other ones, I know that like right here, that's 5. I know that right here is 15. So even though I didn't label those, I can use those to help me graph my data. Okay, now I need to look at my time. I've got time data for up to, I don't know, 7 to 8 to 9 seconds. As I look at this, if I have 10 seconds labeled on this axis, I think I'll be in good shape and be able to use 2/3 of this. So watch how I'm going to do it. Just like I did the other one, I'm going to go every other line. So I'm going to skip this first one. Let's do this in black. And I'm going to put 1 second there. Skip a line, 2 seconds. Skip a line, 3 seconds. All right, so I've got 10 seconds ready for my data. Fantastic. Okay, last thing, and I'm just going to put an example up here. Don't write this down yet. If you're looking at your data table, and let's say you've got time and position, and I'm just going to abbreviate that. And let's say at 0 seconds, I'm at 0 centimeters. At 1 second, I'm just making these numbers up. Let's say I'm at 32 centimeters. Okay, how would I graph that? Well, let's look at the beginning. If I've got 0 seconds, I'm at 0 centimeters. I'm going to go find 0 seconds and 0 centimeters, which would put me in the corner. Check. I've got that one graphed. Now for 1 second, I'm going to go find 1 second, which is down here. And I see that at that point, I was at 32 centimeters. Again, I'm making up these numbers to show you how to do it. So at 1 second, I'm going to go up to 30. That's 10, that's 20, that's 30. I know that this is 35, so 32 must be somewhere in the middle. There's my dot for 32. Check. Let's say that I went on and had a lot of dots that looked something like this. What do I do now? From here, I'm going to go ahead and I'm going to draw a line of best fit. How do we do that? I'm going to draw a line that goes through as many of those as possible through the middle. So watch. I'm going to draw a line of best fit. Oops. I thought I was drawing a line of best fit. Through all those. Oops. All right, here we go. For real now. I see I've got dots all over the place. I don't want to connect the dots on this. That's not going to give me what I'm looking for. What I want to do is draw a line of best fit through most of these. So if I did something like this, that's close to a line of best fit. I've gotten the average of all of those. This is called a line of best fit. Again, I have made up this data. Yours might look different, but the same principle applies. Graph your data, draw a line of best fit, and then go ahead, let's say that this was your warm, label it. I've got warm. When you go ahead and do your cold, whatever it ends up being, label that one cold. All right, that's the basics of making a graph. Go ahead, have some fun.